Hello, my dear students. In the previous class, we have discussed these examples. Some of these examples we have discussed. Okay. And in this example, lastly, what we have discussed is, so this one is what? Functional group here. So this functional group is only one here. Only one functional group is present. When one functional group is present, it is called principal functional group here. So this principal functional group is attached to which carbon? First carbon. And it is second carbon. It is third carbon. So to the first carbon, alcohol functional group is attached. After first carbon, single bond is there. After second carbon, double bond is there. Right. Totally, how many carbon atoms here in the parent chain? There are 3 carbon atoms in the parent chain. Therefore, word root what we have taken prop. And after which carbon double bond is there? After second carbon. That's a 2N. And we have taken OL for alcohol functional group. OL is present on which carbon? First carbon. So here prop 2N 1-ol is the IUPAC name of this molecule, right? Now see, the next example is what we have to discuss is that, see, some of the other examples are like this. Now in this case, here, this functional group is present in this molecule. In this given structure, one functional group is there. So this is itself is what now functional group is called what? Principal functional group here. Principal functional group here. For this principal functional group, which position we have to give? Generally, first position we have to give. First position. Then this carbon, second carbon. This one, third carbon. This one, fourth carbon. Okay. Now, this functional group is what? Carbon containing functional group. Carbon containing functional group. The functional group itself has what? Carbon atom. So it is called carbon containing functional group. And it is called terminal functional group. Terminal meaning what? At the end of the chain, this functional group is present. So it should be allotted first position, this carbon. And second carbon, third carbon, fourth carbon. Now, after second carbon, what is there? Double bond is there. After first carbon, single bond. After second carbon, double bond is there. So 2N. After second carbon, double bond. That's why 2N. And for this aldehyde functional group, what is the name? Secondary suffix name what? Al. Al is the secondary suffix of aldehyde functional group here. And totally how many carbons? 1, 2, 3, 4. Therefore, but. So but 2N al. But 2N al. Between the name and number, there should be hyphen. Between number and name, there should be hyphen. Remember. And between name and name, there should not be any hyphen. There should not be any gap between En and al. Here al is nothing but secondary suffix of CHO functional group. En representing which bond? Double bond. Double bond at second carbon. Like this. It is but 2N al. Actually here En should be given Ene for double bond. For double bond Ene should be there. In this Ene, what is dropped? E. The letter E is dropped because this secondary suffix name. This al is what now? Secondary suffix. Secondary suffix name. The secondary suffix name starts from OL, A. Secondary suffix name of aldehyde. Aldehyde group is what? Al, starting from OL. As the secondary suffix name starting from OL, it should be dropped. E should be dropped here. So instead of Ene, we have tried only En. So 2N al, 2enal, 2enal. Next, in this example, check it. Here, this is the functional group here. Carboxylic acid functional group. This carboxylic acid functional group has carbon. So it is also carbon containing functional group. Carbon containing functional group it is. So it is also terminal functional group. Terminal meaning what? At the end of the chain, it should be present. So it should be allotted first position, this carbon. So first carbon, then second carbon, then third carbon, then fourth carbon, fifth carbon. If you go down like this, 5, 6 coming. Totally how many carbons? 6 carbons coming. If you go straight, 1, 2, 3, 4, 5 only coming. But if you go like this, 1, 2, 3, 4, 5, 6. So it is fifth carbon. It is sixth carbon. So totally 6 carbons coming in the longest parent chain. So this is parent chain. So what is parent chain here? This is the parent chain. It is parent chain. So this parent chain contains how many carbons? Totally 6 carbons. So what is the word root? Root word is hex. And in this here, after first carbon, why it is given first position? Because chain terminating functional group. Chain terminating functional group, that is carbon containing functional group, should be allotted first position. Therefore, first carbon single bond, second carbon double bond, third carbon single bond. So after second carbon, what is there? Double bond is there. So 2 ene. Instead of ene, ene. Again, what we have written here? E and N only. E dropped here. This E is dropped. Why E is dropped again? Here oic acid is secondary suffix. Oic acid is what? Secondary suffix. Secondary means 2 degree. So secondary suffix name is what here? Oic acid. In this oic acid, first letter is what? OL. O, OL. Okay. So when the secondary suffix name is starting from OL, ENE, en should not be written. We have to write only ENN. So 2N after second carbon double bond, and third carbon single bond, after fourth carbon single bond, after fifth carbon single bond. Okay. Next, here what is the principal functional group in this COOH? Is group, and CH3 is branch, substituent, side branch, substituent we say. One more CH3 also substituent. This CH3 substituent is present on second carbon. 2-methyl is there. And this CH3 functional means substituent is present on fourth carbon. 4-methyl is there. So 2-methyl is there, 4-methyl is there. Together what we write? 2, 4. 2, 4. Dimethyl. Totally how many methyl groups? 2. That's the dimethyl. So 2, 4. Dimethyl hex 2N oic acid. So what is the IUPAC name here? 2, 4. Dimethyl hex 2N means oic acid. Here 2, 4. 2, 4. Okay, here between number and number there should be comma. Between number and name there should be hyphen. Between name and name there should not be any gap. So dimethyl. Between di and methyl there should not be any gap. See, a di is what? Numerical or number prefix? Numerical prefix di. 2 and 4 are what? Number prefixes. Number prefixes. So in this way we have to understand the IUPAC name of this molecule. Next, in this case now, it is functional group, cyanide group here. What is this? Cyanide functional group here. This cyanide functional group is also carbon containing group. Carbon containing group is nothing but chain terminating group. Chain terminating group. So this carbon should be given first position. It is second position. It is third position. So 3 carbon atoms totally. So what is the word root? Pro. Between the first and second single bond, second and third also single bond. Only single bonds available here. That's why AN, ANE. Here we are writing completely ANE. This A is not dropped here. In ANE, E is not dropped. Why? Because this nitrile, NITRILE, nitrile is what now here? Secondary suffix. Secondary suffix of which one? CN, cyanide group here. For cyanide group, what is secondary suffix name? Nitrile. Nitrile. So nitrile is the secondary suffix name of which group? Cyanide group here. So nitrile first letter is what? N. Is N consonant or vowel? It is consonant. Whenever the first letter of the secondary suffix is consonant, it's not vowel. This E should not be dropped. E should be there. So N completely we have to write. N indicates which bonding between carbon atoms? Single bonding. A single covalent bond, if it is present, we say N. So E should not be dropped here. E should be there. E should be present. Why? The secondary suffix name is starting with consonant. Therefore, E should be there. So propane nitrile is the IUPAC name of this molecule. Next, one more molecule here. In this case, now check it here. CHO, bond CHO is principal functional group here. Principal means what? Main. So principal functional group is what here? CHO. And what is the C bond OH here? Substituent. It is second grade functional group. What is this? Second grade functional group. That's why it is called what now? Simply substituent. Substituent. Otherwise we say second grade. What we say? Second grade functional group. Second grade functional group, otherwise simply substituent we say. So here it is not at all functional group now. It is simply like Cl, like Cl only. OH also is there. That's all. Here it is principal functional group CHO. So when CHO is present, it is carbon containing functional group, no? Carbon containing functional group or chain terminating functional group. The chain terminating functional group carbon should be given first position. This is first position, and it is second position. It is third position. Third position has what now? Chlorine. So at third locant position, what is there? Which atom is attached? Chlorine is substituent. It is not functional group here. Cl. Cl is simply substituent which is attached to which carbon? Third carbon. Then fourth carbon has which one? OH. OH is it principal group or simply substituent? It is also substituent, like second grade functional group here. Okay, next it is fifth carbon. Anyhow, we don't give number to oxygen here. After carbon 4, this fifth position will not be given to oxygen. Oxygen is not included in the numbering. Numbering should be given only for carbon atoms. Only for carbon atoms. If Cl, are we giving any number? Is it number 3 position or it is attached to number 3 position? Cl is attached to the third position, third carbon atom. And OH is attached to fourth carbon atom. That point we have to keep in mind. So, totally how many carbons include in this carbon? 1, 2, 3, 4, 5 carbons. 5 carbons indicating what is the word root here? Pent. P-E-N-T, pent. Pent means what? 5 carbons. And between first carbon, second single, 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 and single. All single bonds available here. No double bond, no triple bond. That's why ANE, AN actually should be there. Actually, what should be there? ANE should be there. The E is dropped or not in this? Instead of writing A and E, we wrote only A and, that's all. Only A and we wrote. Okay. And now why we have dropped this E here? Because here Al is the secondary suffix of what? Aldehyde group. For aldehyde functional group, what is secondary suffix name? Al, like this here. Here CHO is what? Al, secondary suffix. Like that here also CHO, na? So Al will be there. In this Al, first letter is what? A, vowel. When the first letter of secondary suffix is vowel, this A and E should not be written. And we have to write. So pentanol. And in this molecule now, here on third position, what is attached to chlorine? On fourth position, hydroxy is attached. This group is called hydroxy group. Hydrogen and oxygen, that's why it is hydroxy group. So hydroxy group is attached to which carbon here? Fourth carbon. Chloro group is attached to which carbon? Third carbon. Now chloro first letter is what? C. Hydroxy first letter H. What we have to write first? Chloro we have to write first in the naming. In IUPAC name, chloro word should be written first. Then only we have to hydroxy word. So chloro is attached to which carbon? Third position. They are coming first, second, third position. That's why 3 chloro we have to say. 3 chloro. And 4 hydroxy we have to say. 4 hydroxy. Fourth carbon is attached to hydroxy group. And pentanol. 3 chloro, 4 hydroxy, pentanol. If for this OH group, OL will be given, Al will be given here, or hydroxy will be given. It is given only hydroxy. Here we should not write what now? We should not write what? We should not write OL. OL should not be written. OL should not be written here. We have to write only hydroxy name here. Hydroxy. Is the concept clear? So hydroxy should be used for OH. We should not use OL. Here OH group has 2 names. What are they? Hydroxy is one name and OL is another name. OL is what? Secondary suffix name. And hydroxy is what? Secondary prefix name. So every functional group has 2 names, secondary prefix name, secondary suffix name. Here for OH group in this molecule, for OH group, hydroxy should be used or OL should be used. Hydroxy should be used because OH is second grade functional group here. It is substituent simply. So we should not take OL for this OH. That's why we have said 4 hydroxy. So take the screenshot of this once. So next important concept is that here. Suppose here pent N is there. Okay, in this now, what is pent? Root word. Word root. What is N and here? Primary suffix. Primary suffix. What is E here? Secondary suffix. In alkane, in pentane, what is E here? Last E? Secondary suffix. An is what? Primary suffix. Okay, an is primary suffix. And pent is what? Root word. Pent is what? Root word. Okay, ma'am. So it's about what now here? E. E is what now here? E is called what? E is called secondary suffix. Remember, secondary suffix. Is the concept clear now? So it is secondary suffix. So secondary suffix and primary suffix in ANA. Like that, you take pentene. Tell me in pentene. In pentene, what is secondary suffix? It is E. It is E. Right, ma'am? So in pentene, E is what? Secondary suffix. ENE in that EN is what? Primary suffix like that. So in this here, pentene. In this also, EN is what? Primary suffix. E is what? Secondary suffix. Pent indicates what? It is word root. Word root, otherwise root word. And now check it here. Now in this case, now pent N. In this, how many carbons here? 1, 2, 3, 4, 5 carbons. N indicates which bonding between? First, all single bonds we have to write. Only single bonds here. No double bond, no triple bond. Now a carbon should be having totally 4 bonds now. Here one bond already there here. One bond is there. So it is what now here? CH3, 3 bonds attached here. Here CH2. Because this carbon has already 2 bonds already there. Remaining 2 bonds with the hydrogen atoms. Again here, this carbon has 2 sides, 2 bonds. Therefore, it should be CH2. Here carbon has 2 bonds already. Therefore, it is CH2. Here carbon has only 1 bond. Therefore, it is CH3. So it is what now here? CH. So now numbering we can give 1, 2, 3, 4, 5. Left to right we can give. Otherwise, right to left we can give. Anyone same. No change here. Anyone we can give numbering. It is what now the structure of pentane. And also here, each carbon is having single bond or double bond here. All carbons having single bonds. No double bond, no triple bond. So all these carbons are what? Sp3 carbons. All sp3 carbons here. All sp3 carbon atoms. There is no sp2 carbon. There is no sp3 carbon here. Only sp3 carbons there here. Okay. And also now here, sp3 carbons means they should be having which shape? Tetrahedral shapes. They should have what? Tetrahedral geometries. Right. Now in this case, what we have to write is that the same structure. The same structure we can also write like this here. See here now. CH3 bond, CH2 bond, CH2 bond, CH2 bond, CH3. How many carbons? 1, 2, 3, 4, 5. Zigzag we have tried. Instead of writing a straight line, we can also write what? Zigzag. The reason is what here, see, in this case now here, this carbon has what? Already 2 bonds. Already 2 bonds there here. Now third bond and fourth bond. Now around this carbon, how many bonds totally available? 4 bonds. 4 bonds means what is shape here? Tetrahedral geometry. Tetrahedral geometry. So like this, to have tetrahedral geometry, to show tetrahedral geometry for each carbon of alkanes, what we have to say? We have to show the zigzag lines like this. And need not to show the bond between hydrogen and carbon. Need not to show. Simply write CH2 this one. CH2. So CH3 bond, CH2 bond, CH2 bond, CH2 bond, CH3. Right. It is what now here? The structure, another way. The same thing we can write like this here. Simply 1, 2, 3, 4, 5 carbons. Simply we show like this only. It is called bond line structure. What is it called? Bond line structure. So bond line structure of pentane. So bond line structure of what? Pentane, this one. 1, 2, 3, 4, 5. So here this carbon has how many bonds? One bond only now already. One bond means it should be imagined as CH3. And this carbon has already how many bonds shown here? 1, 2 bonds only. So it should be taken as CH2. This carbon again CH2. This carbon again CH2. And this carbon is having one bond only now. So it should be taken as CH3. So like this we have to imagine it. It is what now here? Bond line structure of what? Pentane. Bond line structure of pentane. The same structure we can also show like this. The same we can show like this here. CH3 bond CH2 taken thrice bond CH3. Now see here, in this case, between this terminal CH3 and this terminal CH3, between the two CH3 terminal groups here, okay, terminal carbon atoms, between the CH3 here, these three CH2 groups are there. See, 1, 2, 3. 1, 2, 3 CH2 groups are available here. So we write what? CH3 bond CH2 taken how many times? 3 times bond CH3. Now it is taken as first carbon, suppose here second, third, fourth carbons, then it is fifth carbon. The second carbon is there here, third carbon is there here, fourth carbon is there, and it is fifth carbon you can take. So it is called condensed structure. What is called? Condensed structure. So condensed structure means what? We have made it condensed structure. So condensed structure like this here. Instead of writing complete structure like this, we have written CH2 taken thrice. Both are same. Okay. So in this way, we have to say condensed structure. This one is complete structure, and this one is what? Bond line structure. Bond line structure. So the different types of representations we show generally. This is one thing to understand. Take the screenshot once. Next, one more thing what we have to understand is that methane. Imagine in this methane, it is word root an primary suffix, and E is what now? Secondary suffix. Okay. Now in this methane means how many carbons? 1. An means what? Double the number of carbons plus 2. Formula what? Alkanes formula what? Cn H2n plus 2. Cn H2n plus 2. Double the number of carbon atoms, double the number of carbons, and add 2. Double plus 2 is called what? Cn H2n plus 2 is called alkane. In this case, double plus 2, how much is CH4? CH4 is methane here. Now in this methane, how many bonds we have totally? We have 4 bonds with carbon atom, with hydrogen. So 4 bonds with hydrogen. So 1, 2, like this here. Okay. Now this bond, this straight line, this line indicates what? Bond line indicates what here? On the plane of the paper. This CH bond, both are on the plane of the paper, on the same plane. Whatever the paper is there on the paper, this CH bond, present, plane of the paper. And one more, we draw like this here, bond. So this is what now here, one solid wedge. What is this called? Solid wedge. What is this called, ma? Solid wedge. Solid wedge bond, this one. The solid wedge indicates what? The bond above the plane like this. From carbon atom, the bond should be imagined towards your face. From this carbon, the bond should be above the plane of the paper. Above the plane of the paper towards your face. This CH bond. This CH bond is present above the plane of the paper. These two CH bonds present on the same plane of the paper. And one more we have to show like this here. It is called dashed wedge. What is called? Dashed wedge. This dashed wedge bond, it is called what now? Dashed wedge. Dashed wedge bond. So this dashed wedge indicates what? The bond below the plane of the paper. If you take this carbon, hydrogen, CH bond on the same paper, and this bond will be CH bond will be below the plane, and this CH bond will be above the plane. Now, all the 4 bonds in the same plane here? No, they are not in the same plane. So this geometry is what now here? Tetrahedral geometry. Tetrahedral geometry. This tetrahedral geometry, is it planar geometry, non-planar geometry? It is non-planar geometry, non-planar shape, because all the 4 bonds in the not in the same plane. These 2 bonds on the same plane. This bond is above the plane of the paper. This bond is below the plane of the paper. So this is called 3D structure of methane. 3D structure of methane. So 3D structure means what now? We have to show the bonds in 3 dimensions. In 3 dimensions. Okay, it is 3-dimensional structure. So 3-dimensional structure of the methane like this. So it's about what now here? The 3-dimensional structure, and tetrahedral geometry is not the planar. It is called non-planar geometry because all the 4 bonds are all the 4 bonds not in the same plane. That's why it is non-planar geometry. Is that concept clear now? And what is the bond angle between any two here? 109 degrees, 28 minutes. Because sp3 carbon it is. sp3 carbon, why? Because this carbon with all single bonds around it, 4 single bonds around it. When carbon has all 4 single bonds, it should be sp3 carbon. sp3 carbon. sp3 carbon means in this sp3 carbon, how many hybrid orbitals are there? 4 hybrid orbitals will be present. How many hybrid orbitals in this carbon? There are 4 hybrid orbitals because one s orbital mixed with 3 p orbitals here totally. So 4 hybrid orbitals are present. Generally, carbon will be having what? 1s2, 2s1, 2px1, 2py1, 2pz1. In this here, sp3 meaning what? It is anyhow inner orbit. It won't involve in the hybridization. Only valence shell, outermost orbit, will be involved in hybridization process. In hybridization process, which will be intermixed, only the orbitals of outermost orbit will be involved in hybridization. Now, sp3 meaning what here? One s orbital mixes with 3 p orbitals. No? So here s orbital is mixing with 3 p orbitals. A 3 p orbitals are what? Dumbbell shaped. S orbital is what? Spherical shaped. The spherically shaped s orbital will mix with 3 dumbbell shaped p orbitals. Then what happens now? These 3 orbitals will be intermixed with each other to form totally how many hybrid orbitals? 4 hybrid orbitals. So 4 hybrid orbitals will be present in this sp3 carbon. In sp3 carbon, how many hybrid orbitals will be there? 4 hybrid orbitals. And any pure orbital left over in the outermost orbit without involving in hybridization? No. Here S is involved, 3 p orbitals involved. All the orbitals are involved. All the pure atomic orbitals are involved in the hybridization process. As one s orbital mixed with 3 p orbitals, it is called sp3 hybridization. And how many hybrid orbitals formed in this carbon? 4. And any pure p orbital left over in the outermost orbit of carbon here? No. No pure left over. Therefore, we write what? 0 pure orbitals. A pure orbital will be taken as what? Generally, PO it takes short form. HO means what? Hybrid orbitals. So how many hybrid orbitals in the carbon of methane molecule? There are 4 hybrid orbitals present and 0 pure atomic orbitals left over on this carbon. Okay, so it is tetrahedral geometry. About what? Tetrahedral geometry. Now next one. Once take the screenshot of this, I will erase it. Take the screenshot once. Yeah, now next thing what I understand is that suppose you imagine it in. It means how many carbons? 2 carbons. Here in indicates for double bond. Between 2 carbons there should be double bond. Every carbon should be having how many bonds? 4 bonds. Already 2 bonds there, na? So third bond with one hydrogen, fourth bond with one hydrogen. For this carbon also already two bonds there na. So third bond with hydrogen and fourth bond with hydrogen. It is CH2 double bond CH2. What is this? CH2 double bond CH2. So the same structure, how to write now? CH2 double bond CH2. The same thing we write like this, CH2 double bond CH2. Here C double bond C. Here also C double bond C only. Don't imagine that between hydrogen and carbon here double bond. The double bond is always between carbon here. The same thing we can write like this here. Like this. So in this structure here, this is one carbon with double bond. This is one carbon with double bond. We have to imagine. This carbon with double bond. This carbon with double bond. Here this carbon CH2 carbon. This carbon also CH2 carbon. We have to imagine. Okay, it is double bond carbon. So here one carbon is there. Here one carbon is there. Between the two carbon, double bond is there. So in this double bond, one is what? One is pi bond. One is sigma bond. Here all these remaining all sigma bonds. All single bonds are sigma bonds. In the double bond, one sigma, one pi bond will be there. Now see here in this case now, each carbon has which shape? Tell me here. What is shape around the each carbon? Shape of the carbon. Is it tetrahedral? No. It is trigonal planar. Trigonal planar geometry. What is trigonal planar geometry? It is trigonal planar geometry means what? Sp2 hybridization. Sp2 hybridization. Now Sp2 hybridization means what? One s orbital mixes with two p orbitals. Now carbon, if you take 1s2, which is the innermost orbit, then in excited state 2s1, 2px1, 2py1, 2pz1. Now in this case here, what happened? One orbital not involved in hybridization. One orbital not involved in hybridization. Okay. Out of three p orbitals, one is not involving. Only what is happening? One s orbital will mix with two p orbitals only. Out of px, py, pz, only one will be involved here. Generally, we take the axis like this here. Okay, so it is 2px double shape, and it is 2py one double shape here, and it is 2pz double shape. You take like this here. Now what happens is that this s orbital mixes with the 2py, 2pz like this. These orbitals will be mixed. How many s orbitals? One s orbital in the outermost orbit. One s orbital in the outermost orbit mixes with the two p orbitals only. This pure 2px orbital not involved in the hybridization. This pure 2px not involved in hybridization. Here how many mixed? One s orbital and two p orbitals totally. Totally three orbitals mixed na. Therefore, how many hybrid orbitals will be formed? Three. Hybrid. Which hybrid? Sp2 hybrid. Hybrid orbitals are formed. How many hybrid orbitals are formed here? Three. Sp2 hybrid orbitals are formed. Okay. So it is which carbon now? Sp2 carbon. In Sp2 carbon, what happens now? Three Sp2 hybrid orbitals will be there. And this is what now? One pure orbital. What is there now here? One pure p orbital. Pure p orbital is left over. Px or py? Px is left over. So one pure 2px orbital is left over, not involved in hybridization. This is not involved in hybridization. Now in every sp2 carbon, there will be three hybrid orbitals of sp2 and one pure p orbital left over. Is the concept clear? So it is about what now? Hybridization. So every double bonded carbon, if carbon has at least one double bond, that carbon must be taken as sp2 carbon. This carbon also sp2 carbon. sp2 carbon has which geometry? Trigonal planar geometry. In this trigonal planar, what happens now? Bond 1, bond 2, bond 3. All the three bonds in the same plane, remember. This double bond plane, this single bond plane, this single bond plane. All the three bonds in the same plane, remember. Same plane meaning what? Planar geometry. So this trigonal planar geometry is what? In the name only it is a planar geometry. But tetrahedral is what? Non-planar. Tetrahedral is non-planar geometry. That point we have to understand. And if you take now here, this we'll discuss tomorrow. About this we'll discuss tomorrow. Suppose you take C2H2. C2H2 is called ethine or acetylene. What is this? Acetylene. Acetylene or ethine. In this case, two carbons with triple bond and one bond with hydrogen. CH triple bond CH. Yeah, this carbon is what now? sp carbon. This carbon also sp carbon. Sp carbon is what is shape? Linear. Linear shape will be there here. Linear shape means here in every sp carbon, how many hybrid orbitals will be there? Two hybrid orbitals will be there. Two pure orbitals will be there. Two hybrid and two pure. In every sp carbon, there will be two hybrid orbitals and two pure orbitals not involved in hybridization.